Okay. So I was, yeah, for Amna, I was repeating this integral part. We understood differentiation, right? So now let us talk about the inverse of differentiation. So differentiation was what? Differentiation was, yes, yeah. So differentiation was calculating the very small relative change. Now integral is just adding those small changes. So when we add all those small changes, so it is called the integral, right? And yeah, so it is of two kinds, right? Let's say that whenever I place some limits, right? So whenever I place some limits, then it is called the definite integral. And whenever you don't have any limits, so that is called the indefinite integral, right? So let us take an example. Let's say that I have an algebraic function. So I talked in the previous class that whenever I have an algebraic function, right? So okay, uh, yeah. So whenever I have the algebraic expression, so integration is simply xn plus one divided by n plus. Okay. So let us remember this algebraic integration and then we'll do. So then we will understand what is about what is the difference about definite integral and the indefinite integral. So let's say that I have a function which is right. I have a function which is x 3x square. Okay, I have this 3x square, and then I want to integrate this function. So I want to integrate this function. So this would be how much? This would be 3x square dx. Okay. So 3 is constant term. It will be taken outside and I have this x square dx. What would be the integral of x square? Power is n. And we know that xn is xn plus 1 divided by n plus 1. So this would be 3 into x 2 plus 1 divided by 2 plus 1. So this is 3x cubed by 3. This is x. So you see that there was no limit on the integral. Okay. There was no limit on the integral. So this would be the answer. Understand? Now if I put some limit on the integral, so find, so if I say that find the integral of 3x square in the limit 1 to 2. Okay, so this is the lower limit, this is the upper limit, right? So I have to calculate the integral which is 3x square dx in the limit 1 and 2. So the process are all the same. Up to integration, the process is exactly same. 1 to 2 x square dx and this is again 3 x cubed by 3. Now there is the change that it involves. So in this this was already this one. But for the definite integral, we put the limits. So we have 2 and 1, right? And then this is 3 is constant, so we take it outside. This is 3 by 3, and this is x cubed 2 to 1. So the difference is that first we put the upper limit, right? Upper limit and then minus the lower limit. Upper limit function and then lower limit function. So what do I mean by that? I meant to say that x cube, the function is x cube. So what is the upper limit to? So the function in place of x, I put 2. So this would be 2 cube and minus of now in place of x, I put 1. So 1. So this would be 8 and minus 1. So this would be 7. So this is the difference between the definite and indefinite integral. So indefinite is ended at this point. But if we calculate the limits, then we have to put the limits and this would be the solution. So is that clear to you guys? Yeah, understood. Yes, guys, any doubt?
No, sir.
Okay, so you guys please note it down and then I will talk about the. So then I will do one question and then I'll talk about the equation of motion using the integral. So this is what I wanted to do and so enhance just. My voice is low. So again, Akib, Amna and Rishita can hear me can hear me clearly. So check your. Okay, so let me. Yeah, am I audible clearly now? Okay.
Yes, sir.
Yes, yes, Ilham. Assalamu alaikum.
Walaikum assalam. Sorry, so my laptop it wasn't starting and
Yeah. So okay. Yeah,
yes, sir.
there can be technical issues. So
Yes.
what I was yeah. So what I was telling that we studied two kinds of integration in the previous class. One was the definite integral and the other was the indefinite. So let me repeat this for you and you just take the screenshot. So we had two kinds of integral, right? The indefinite integral and the definite one. So whenever we don't have limits on the integral, so that is called the indefinite. And whenever we have the limits on the integral, so that would be called the definite integral. Okay. Now, what is the calculation involved with these definite and indefinite integral? So let's say that I choose a function which is 3x squared, and I take the integral of this 3x squared. Okay, and what do I know is that for the algebraic function, this is the integral. So integral of xn dx, this is xn plus 1 divided by n plus 1. So I have this function 3x squared dx. Okay, so I take 3 outside and function is only x squared. So this is power 2, right? So what I will do is that I will add 1 to the power and then divide with the addition of the power. So then I will get this. So this is the indefinite integral of f. Okay. Now what I do is that I place the limit on these integrals. So I place a limit on this integral and the limit is 1 and 2. So this is the lower limit and this is the upper limit. So what I do is that when I integrate, I get this x cube by 3 again. And 3 is constant. So this is taken outside, 3 cancel, and I have x cube. Now the function is x cube, right? So in the whenever we have the limits on the integral, so what we do is that first we put the upper limit in the function. So function is x cube. And if I put the upper limit, which is x equals to 2, so this would be 2 cube, right? And then we subtract it with the lower limit function. So I put 1 in place of x. So this is 1 cube, and then I get this answer. So this is what I talked about in this class. Is this clear to you, Elham?
Yes, sir. Thank you, sir.
Okay, so you just take the screenshot of this part you already noted. So just take the screenshot of this part and the rest part. And Rishita, Akib, and Amna, did you guys note it down?
Yes, sir.
Okay, so Ilham, you take the screenshot. And
Yes, sir. I took.
yeah, then this one also.
Yes, sir.
Okay, so now we will get the hang of the integral, and then we will talk about the equation of motion in the integral form. So first, let us solve. Let me give you a question, guys. So let's say that I have y is equal to, let's say, 4x squared plus 3x plus 2. Okay, this is the integration. Remember, this is integration. So don't write integration of 2 is 0. Differentiation of 2 would be 0. So find the integral in the limit 2 and so please do this
Sir,
question. Yes,
your voice is low.
my voice is low, so you are also hearing my. Okay. I have increased the volume to the maximum. So let me see. Let me check the audio settings. Output is yeah. Microphone is this. Audio settings. Input level. Output level is maximum. Input level. Okay, let me increase the volume. Let's see why this. Hello. Am I audible now? Yeah, I can hear that it is clear. So you guys increase your volume. I guess from here I can hear my voice clearly. So yeah, can you guys hear me now?
Yes, sir.
Okay, so yeah, you guys please do this question and then you will be able to understand the next part that will. So you guys first try this question. Okay, and remember that this is the function that we are calculating the integral with. So we are calculating the integral with respect to x. So please do this question quickly, and then I have to complete the calculus derivation of this equation of motion, then free fall, and then graphical solution also. So we have only three topics which is remaining, and then okay. So this chapter will be completed and vectors, vectors. Yeah. So I need to take some extra class. So Amna and Elham, can you guys come tomorrow? Because yeah, you have a class at 9 p.m. which is what 6 6:30. So at 6:30 you have a class, right? So can you guys come to not 4, so that is 2:30. Can you guys come in at 2:30? Amna and Ilham, so that we can take the extra classes for the vector portions. Yes.
Sir, tomorrow 2:30?
Yeah, tomorrow 2:30 KSA, which means 5 p.m. 5 p.m. IST, Indian Standard Time. 5 p.m. IST to 30 KSA.
Yes, sir.
Okay, yeah. So then we will take the differentiation we have talked about, right? And integration I also talked about. So then you guys only need the backup classes for the vector portions. So yeah, uh, please come tomorrow and then I'll talk about those vector portions, right?
Yes, sir.
Okay, Amna, you too, right? So
Okay,
Amna and
sir.
Ilham, and yeah, Rishita and Akib, if you guys want to attend those classes, so yeah, welcome also. But yeah, just for the revision part, if you want to come, then come. Otherwise, yeah, if you don't want to, so it's up to you. For Akib and Rishita. Yeah, did you get any answer, guys? So we want to calculate, right? This is a definite integral. So we want to calculate 4x square plus 3x plus 2 in the limit, right? So yeah, so whenever somebody is to you that be in the limit, so just ask that what is the limit? Okay, what is the lower and upper limit? So this is the limit that we have, right? And then we just separately integrate these quantities. So one would be 4x squared dx, 2 to 4, right? And then this is 2 to 4 dx, dx, and then this is 2 dx. So this is the integral. And what did you guys get? Yes. Did anybody get any answer? Hmm. Yes. So any answer, guys? Or still calculating? Yes, guys.
Just a minute, sir.
Yes, any answers, guys? So let me solve this and you guys please check your answer. So 4 is taken outside and this is x square dx, right? And then 3 is taken outside and this is x dx. And then 2 is taken outside and this is 2 4 dx. Right. So then this would be how much? X square is x cube by 3. And we have to put the upper and lower limit also. And this is 3 by 2. So 4 and or let me write it as. So let me write it as so that I don't skip any. So this is 2 plus 1 divided by 2 plus 1. This is 1 plus 1 and divided by 1 plus 1. And so this is x to the power 0, right? So I can simply write this as integration of dx is simply x. So this would be 4. So integration of d of y would be simply y. Integration of d of x would be simply x. Integration of anything, d of let's say uh, whatever. So z also. So this would be z. Just remember. Okay. So these are the terms that we will have. And first we have to put, so 3 is taken outside. And then this is x cube 4 2. And then 2 is taken outside. And then this is x square 4 2. And then we have x and 4. So we have to first put the upper limit and yeah, so first we have to put the upper limit. So this would be how much? Rishita, this would be how much?
X raised to 12.
No, so I have to put x 4 in place of x. Function is x cube. Function is x cube, and I have to put
So 4
4.
cube.
Yes, 4 cube, and then minus of, yes, the lower limit. So
2 cube.
2. Right. So this would be the answer, and 3 by 2, and Akib, what should be here? Okay, Akib, Mike is. So Amna, you tell me what should be here. In place of x, I have to put 4. So what should be here? Yeah,
4 square
yeah, 4 square and then minus
minus
of,
2 square.
yes, correct, correct. And now Elham, you say. So what would be here?
So 4 minus 2.
Yeah, 4 minus 2. Good guys. So 4 minus 3 into how much is it? 64 minus 8, and then 3 by 2, 16 minus 4, and then this is 2 into 2. So the answer would be how much? So this is how much? 56, right? Plus 3 by 2 into this is 12. So 6 and 4. So this is yeah, this is a long plus 22. So I guess this would be, yeah. Okay, this is the integral, right? Is this clear to you guys? Can you guys solve this part? So any doubt for this integral? Yes. Do you guys have any doubt? if you guys don't have any doubt, please note it down, and then we'll come to the physics part. So please note it down, and whenever you have noted it down, please tell, so that I can scroll down the screen and then talk about the next topic. Yes, so whenever you guys have noted it down, please tell.
Sir, I'm done.
Yeah, Ilham and Amna and Akib.
Sir,
What
can you
about
scroll down?
Sir, I wrote.
you guys? Please complete. And let's see if you guys remember the equation of motion or not. So, whenever you guys have completed a please tell.
Done, sir.
Sir,
Yeah.
done.
Yes, Rishita and Akib. Done?
Done, sir.
Okay, so now, yeah. What are the three equation of motion, Ilham? Yes, Ilham. What are the three equations of motion that we have? Yes. Do you remember? Or you have forgotten? Okay, Amna, you tell me. What are the three equations of motion?
So I
Yes.
remember. Sir.
Oh, yeah, Ilham. So you tell.
Yes, sir. V is equal to U plus AT.
Yes, correct. And then,
Um, V square
yes,
is equal to U square plus 2AS.
yes, correct.
I
And then
don't
the,
remember the third one.
yeah, so this is SUT plus half VT square. This is the,
Yes, yes.
okay, so these are the three equation of motion and they are, of course, they are valid only for what kind of motion? Or let me ask this precisely that what kind of acceleration these are. So for what kind of acceleration these are two?
Uniform acceleration.
Yeah, uniform acceleration. So here A is constant. Okay. So for all these three cases, A is constant. Right. So uniform accelerated uniform acceleration. Now, what do we know about the instantaneous? So, what is the instantaneous speed? What is instantaneous speed?
The speed at a particular point.
Yeah, and this is how much? Yes, this is with respect to display distance. This is how much? So, dx by dt. Right. This is and also, what is acceleration? This is dv by dt. Is that clear, guys? these two part. This we already did, right? Yes. So is that clear to you guys?
Yes, sir.
Now, using these equations, so using this one and this one, we want to reach here. Okay, so first let us use this one, right? So first we know that acceleration is dv by dt. Okay, what we do is that we take this in the left hand side. So dv is a dt, right? And this is dv. So how can we get v from it? We can integrate, right? And then we will get v. Is this clear? Yes. Is this clear?
Yes, sir.
Okay. So, but before we do that, let us first know about the prior information that we have, right? So the information is that we are at initially the time was 0, right? And at this time, the speed was initial speed, right? And at this time, position was let's say 0. Okay, so this is the prior information that we have. And at final time, my final velocity is v, and final time is t, and my position is, let's say, s. This is the information that we have. Is this clear?
Yes, sir.
Okay, now we will integrate. So integrating on both these sides. So we have dv and a dt and integral. So you guys see that in here the integral is with respect to what? Speed, right? And in here the integration is with respect to what? Time, right? So in here the limit would be of speed, and in here the limit would be of the time, right? So what is the lower limit that we have for the speed? What is the lower limit? Yes, guys. What is the lower limit? What is the starting velocity or the speed?
Sir, 2.
Is it you?
Oh, yes, sir.
You.
Yes, sir. Yes.
Yeah. My handwriting is that, but it is. Is it looking too? So this is you. And what is the final velocity? The upper limit? Yes. What is the final velocity? The upper limit. Let's look at from here.
V.
So it will be right. It is about this integral. So what is the initial time? Initial time is 0,
0.
and final time is t.
T.
So now we have all the limits and we have the integral. Okay. So as I've said you guys earlier, that integration of this kind is simply this, right? Integration of dx is simply x. Integration of d of, let's say, w, this would be w, right? So integration of dv would be v, and then we put the upper limit and the lower, right? And a is constant or variable?
Constant.
Constant. That is why we get the equation of motion, because this is constant, so we can take it outside and then this becomes 0 to t and dt. So then this becomes a t, and then we put the upper limit and the lower. Okay. So when we put the upper limit in here, so this will become v, and then we put the lower limit. So this is v minus u, and then we put the upper limit minus lower limit. So this would be how much? V minus u would be at. So v would be u plus at. This is the first equation. Is that clear to you guys? Yes.
Yes, sir.
Okay. So you guys please note it down and remember this condition. And then we'll solve the second equation. So Akib and Shita and Amna, if you guys have any doubt, you can ask, or then we can solve the next equation. Whenever you guys have finished noting it down, okay. And the rule of my class is that you don't have to hesitate. So if you have any question, the rule is that you don't hesitate in asking any question, right? Don't think about the kind of question that you ask. So yeah, don't bother about those things, whether it is correct or wrong. Just ask if you have any doubt or any question. Okay, that is the one and only rule that we have in our. Akib has finished noting. What about rest of you guys?
I finished, sir.
Yes, even me.
And Amna, what about you?
Yes, sir.
Okay, again, so now we have to prove that the second equation is what? S equals to ut plus half at square. This we want to, right? So just see that we have distance, right? So in which differentiation we get the distance? So we have this differentiation. A is dv by dt, and v is dx by dt. So in which differentiation we are getting the distance? Yes. In which differentiation we are getting the distance? First or second one?
Sorry, sir.
Yeah, in which differentiation we are getting the distance? So this one or this one? Which have the distance? Yes. So let's see this differentiation. This has acceleration, speed, and time. So this does not contain distance, right? And this differentiation, we have speed, and this is distance, and this is time. So this differentiation contains distance, right?
Yes, sir.
And we want to get distance in whatever we want to prove. So in that we have distance. So which should be suitable to solve? This one or this one? This one, right?
Yes, sir.
Okay, so let us use this. B is dx by dt. Okay, and now let us take this in this side. So dx is b dt. right? But because this is the integration with respect to t, but we don't have a function of speed which is of the function of time, right? So can we change this to some function of time? Yeah. Can we change this somehow to some function of time? Okay, v is u plus at, right? This we know. This is constant and then this is constant, right? We know this, right? So we can plug in this value and then solve. So let us solve. So we have integration of dx and integration of v. So we just plug in the value. So this is u plus at, right? Integration and dx and integration. So this was, now the integration is with respect to distance. So we have the initial distance 0 and final as okay. And the integration is with respect to time. So we have 0 and t. Is that clear to you guys? Yes. Yes.
Yes, sir.
Yes, sir.
Okay. So dx integration would be x and the limit is s and 0. And let us talk about this integration. So this has plus. So first is u and dt plus at dt limit 0 to t. Okay. So let us solve this integration. U is constant, U is taken outside, and this is 0 to t dt plus A is taken outside and integration of t dt 0 to t. So again, this is, we have to put the upper limit and lower limit. So Rishita, you tell me, what should be here? If you put the upper limit and lower limit.
5 minus 0.
Yeah, you said I.
5. 5.
This is
S.
S. So you guys are making fun of my handwriting. So yeah, S minus 0. And again, you see that dt integration would be t. So t and 0. And what is the integration of t? Power is 1. So t square by t to 0. Understood? Yes, clear guys.
Yes, sir.
Yes, sir.
Okay, so now let us put the upper, and this is S. And now we have to put the upper limit. And so, Amna, you tell me what should be here. Yes,
T minus 0.
minus. Correct. And Elham, you tell me what should be here. So I have taken 2 to this side. And what should be here?
I'm
Yes,
not
please.
sure, sir.
So we have to put t in place of t, right? So this is looking like say, and the function is t square. Function is t square, and first we have to put t and then we have to put 0. So one would be t square and the other one would be 0 square. Is that
Yes, sir.
clear? Yeah.
Yes, sir.
So let us just solve this. So this is ut and this is at and this is t square. So we get what? We get ut plus half at square. This is our second equation. Right. So you guys, if you guys have any doubt, you ask me and please note it down. So Yes, sir. Please unmute. Whenever you guys need me to scroll down the screen, that's it.
Sir, can you scroll down?
And whenever you guys have finished noting,
Done, sir.
then, Rishita, Amna, Kev, what about you guys?
Done, sir.
Done, sir.
So now the third equation, right? So again, we have a third equation, which is what? Which is b square minus u square, it is z, right? So again, we see s, right? We see s and we see v. So we have v, which is dx by dt, right? And we have a, which is d by dt. Okay. So you guys see that we have what? So can we get uh, we have this distance, right? And we have this velocity and we have this acceleration. So in this part we don't have acceleration, right?
Yes, sir.
So let us remember that, keep in mind, and in this part we have acceleration. Okay, but in this part we have distance, and in this part we don't have distance. Okay, so we cannot get acceleration from this equation. So we will discard this and we will use this one. But the idea is that we have to get the distance somehow. So how can we do that? So let's say that I want to change the dependable function or the independent function from t to some other function, which should be distance. So let's say I multiply this with dx and dx, right? So this is doable, right? Did you guys understand this part? Yeah. Is this clear to you?
Yes, sir.
Because
Yes.
yeah, because I wanted this displacement, because you see that there is no function of time in this there's no function of time in this equation. So we have to get rid of this guy, right? Now you guys tell me that what is dx by dt? What is dx by dt? Yes,
We.
v. So this is v and this is gv by dt. So now you guys see that. I have changed this differentiation with respect to this x, right? I don't have this differentiation with respect to time. So is this part clear to you guys? Yes. Is this clear to you guys?
Yes, sir.
Okay, now let us solve this differentiation. So we have A, which is v dv by dx, right? And we put this in the other side. So this is A dx, and this is v dv. So v dv is equal to A dx, right? This is constant, so we can integrate this, and this is function of v, and the integration is with respect to v. So all things are okay now, right? So we integrate on both the sides. So this will become integration of v dv and integration of e dx. So remember that the limit of velocity is u to v, and limit of distance is 0 to s. Okay. So this is integral of v dv. So what would be this integral? Yes, Elham, you tell. What would be this integral? Yes.
Mm,
Just see that this is an algebraic function. The integration with respect to is v, and we have this v. So if I write it in this way, then this would be more clear to you, right? This is the same function as this one. Only the only the notation has changed. So what would be this integral? If I ask you this integral, so this is how much? Yes, this is x to the power 1, so this would be how much? Yes, think about it. So integration of x dx, what power is 1? And we know that x n dx is xn plus 1 and n plus 1, right? So this would be how much? Yes, Amna, you tell. Yeah, we did this
X,
same. Yes,
x1 plus 1,
yes, and
1 plus 1
right.
divided by.
Yeah, so x square by 2. This is the same thing that we did in here. Why didn't you guys ask me that? T dt, right? So this was t square by 2. I directly wrote the answer. So you guys have to, sir, why did you, why, how did you get this answer? So this is t dt, right? So this would be t 1 plus 1 divided by 1 plus 1. So t square by 2. Similarly, we have, did you get this point, Ilham?
yes, I got it now.
So this would be what? This would be v 1 plus 1 divided by 1 plus 1. So v square by 2. Is that accurate?
Yes, sir.
Okay, so now let us plug in the values. So we have v square by 2, and the limit is v, and so, and in here a is outside, and the integral is dx. So this is 0 to s. So half is outside, and Rishita, you tell me what would be here. Yeah, first I have to put v and then q. So what would be here?
So v square minus U square.
Yes. This is this and integration of x and from S2. So this is v square minus u square divided by 2. And this is what? A s minus 0, which is a s. So this is how much? This is v square minus u square by 2 as. So v square minus u square, and this 2 comes here. So 2. And we can also write it. So this is the third equation. Is there any question, any doubt, if you guys have? Yes. So do you guys have any doubt or question that you want to ask? No doubt. Okay, so then just please note it down, and then we will start the other talk. And whenever you guys need me to scroll down the screen, guys. So this part was important. Finish. So should I scroll down the screen, guys? Yeah, whenever you guys have finished noting, please.
Done, sir.
Okay.
Yes,
Rishita
sir,
and
done.
Ilham. Okay. Okay. So now let us do some question based on these three questions. I will also talk about yeah. I will also talk about the graphical solutions. Okay. So graphical derivation also, and yeah, because there would be a class assessment on this topic, on these three equations of motion. So okay, but before I do that, there is one more formula that I want to that I want to talk about. So let's say that let's say that a body is moving, right? And let's say that if I am at this right, so at this point, let's say this is T, and this point is t plus 1. So I know that what is the distance, right? I know that what is the distance covered in this time, right? And I also know that what is the distance covered in this time. So what I can do is that how much distance is covered in this time I can calculate, right? This is st and this is st plus 1. So this is the distance covered in total of t plus 1 time, and this is distance covered in t time. But now I want to calculate the distance covered in, let's say, t plus 1th time. Or let me write it in this. So this would be more clear. Let's say that, yeah, so let's say that this distance I know, this is time t. Okay. And this is S. And before, let's say this is t minus 1 time. Right. So that would be also be clear, but let's say I want to say it in this. So in this way, this would be the distance covered is st minus. Right. Let me write the number so that you guys can understand. So this is t equals to 9 seconds, and let's say this is t equal to 8 seconds. So this is S9, distance travel in 9 seconds, and this is the distance travel in 8 seconds. Okay. So, but if I want to calculate the distance travel in the tth second, or let's say distance travel in the ninth second, right? So the distance travel in the ninth second is this much, because up to 8 seconds this was the distance that it covered, and in 9 seconds it covered this much, this much distance. But if I want to calculate the distance covered in this much time, ninth second, right? So this would be the distance. Is that clear to you?
Yes,
Is this
sir.
part? Yeah. So this is the distance traveled in the tth second. Okay. So this is distance traveled in the tth second. That would be the total distance covered in the t time, and the distance traveled in the 1 second or one time before that time. Right. So this is t minus 1 time. Or if I write the numbers to make it more clear, so if I want to calculate the distance traveled in the 9 seconds, so what will I have to do is that I calculate the total distance traveled in the 9 seconds. And what I do is that I just subtract it with the distance traveled in the 8 seconds. So distance travel within the 9 seconds, distance travel in the 8 seconds. If I subtract that, so I will get the distance traveled in the 9 seconds. Okay, is this part clear to you guys?
Yes, sir.
Okay, so let us derive the formula for that. So STH, and people write it as SNH. So let me write it as distance traveled in TH second. Right. So this would be STH, and this is ST minus ST minus 1. So from the second equation of motion, ST is what? UT plus half a t square. Right? Is this clear to you guys?
Yes, sir.
Okay, so you guys tell me what would be ST minus 1. In place of t, I am replacing it with ST minus 1. So what would be here? Hmm, who is going to tell? Yes, Elham. So you tell. What would be S travel in distance travel in t minus 1 seconds? Just remember that I have to put t minus 1 in place of t. So yes, Amna.
So
Yeah, yes, yes.
ut minus 1,
Yes, absolutely right. Ut minus 1, then half, and
at minus 1 the whole square.
yes, absolutely correct. Good. So this would be ft minus 1. Is that clear to everyone? Okay, so now just plug in the values. So this is ut plus half at square minus of ut minus 1 and plus half at minus 1 whole square. So this is ut plus half at square minus of ut minus 2 and plus, okay, I have to simplify this. So half a t square plus 1 minus 2 a t. Right, guys? A minus b whole square. So a square plus b square minus 2. So this will become what? So I have ut plus half at square and plus minus ut plus u minus of half at square, right? And minus of okay, minus of half a and plus of 2a. Is this clear to you guys?
Yes, sir.
Okay, what is cancelling? So we have this one. Yeah, half at, oh, half at, right, into 2. Why did I write 80? So this is 2t. So this is 2 by 2, right? So half 80. Yeah. So 80 square cancelling, ut cancelling, and I have what? U minus of, let's say this is half, and this is A, and this is, so if I take this is 1 and minus of T, right? So if I write it correctly, so this would be U minus, or if I write plus, so half A and 2t minus 1. So this would be the distance travel in the nth second. Is that clear, or if you guys have any doubt? Is this clear?
Yes,
Or
so clear.
okay, so just write this. So the distance travel in the tth second would be just q plus half and a 2t minus 1. Please note down this diagram. Okay, note down this diagram and then just derivation. And if you guys have any doubts, so you can ask. So whenever you guys need me to scroll down the screen, you guys. Yes, should I scroll down the screen, guys?
Yes, sir.
And let me also see the calculation. Minus uh, square plus 1 by q t comma t minus half. Okay, you can write it in this way or this way also. So u plus a t minus half. Whichever, so t minus half. Whichever way you want to remember. Whichever way you seem that it is easy to remember. Yes, so if you guys have noted it down, please tell.
Done, sir.
Done. Rishida, okay, Vamna, what about you guys?
2 minutes, sir.
Okay. So all these, so this topic is based on the uniform accelerated motion, right? So just remember this. So today's class assessment would be on the uniform accelerated motion. And then we will have two topics which is remaining. One would be free fall and then the graphical derivation. Let's see. Then this chapter will be finished and then I'll start next chapter. So in the next chapter, you have only two topics. And that would be projectile motion and the circular motion. So that will take a very less time to complete. Because in the next chapter, in the motion in a plane, the major portion was this vector portion, vector part. But that I have already talked about. So yeah, what I will do is that I will just only talk about the projectile motion, the circular motion, and vector representation of all these motions.
Done, sir.
Okay, so yeah, Rishta, done.
Yes, sir.
Okay, so let us do some question based on the. So, car is moving with 20 meter per second speed, right? So then with the acceleration, let's say 3 meter per second square. So calculate the distance
Sir,
traveled. Yes.
it is 10
Yes.
or 20.
Which one? This one.
Yes.
This is 20. Did I say 10? Yeah. 20. Okay. So So a car is moving with 20 meter per second speed with the acceleration 3 meter per second square. Calculate the distance traveled in 5 seconds and in 7th second. So these are the two questions, I think. Okay. So in the first question, we have to calculate the distance traveled in 5 seconds, total 5 seconds. And in the next question, we have to calculate the distance traveled in the 7th second. Okay. So we have two formulas, right? S is ut plus half at square, and then we have s nth or tth. So this is how much? This is u plus a t minus half, right? So in this part, let's say this is one and this is the second. So in this part, we will use this one, and in this part, we will use this, right? So let us solve this first. Okay, you guys calculate and tell me the answer. So you guys calculate and tell. What is first and what is the second? Yes, are you guys calculating? This is how much? 37.5. So 137.5 meters. Right, and the second question is what is 7? So this would be what? 20 plus 3 and 7 minus 1. So 20 plus 3 and 13 by 2, right? So 20 plus 39 by 2, so 20 plus 19.5, so 39.5 meters. Yes, did you guys get this answer? Yes, guys.
Sir, first one I got.
Yeah, first one you got 130. So did you get 137.5 or the other one?
What, sir?
Yeah. So did you get the same answer or different one?
Same.
Yeah, and yeah. So please just do or please note down this problem and then log into your Learnivio account. So whenever you have finished noting or doing the calculation, please log into your Learnivio account and then yeah, and then see the class assessment section. So there you will find some active test. Yes, did you guys yes finish? Then please log into your Learnivio account, and then in there in the class assessment section you'll find an active test. So please take that test. Okay, guys. Rishida, Ilham, Amna, and Akib, you guys please
Yes,
take
sir.
that test.
Yes, sir.
Okay. So if you guys find any problem in yeah in finding that active test, so please take. Yes, started the test, guys.
Sir,
Yes.
I finished it.
Oh, you have finished the test. Okay, so
Yes,
yeah,
sir.
then you can okay. Yes, Allah Hafiz, Allah. Bye, bye.
Yes, sir.
And
Hafiz.
yeah, so how? Okay,
Sir, I have the other test, the fortnightly test. I didn't do it yesterday, so I have to do it now.
okay. You have the questions with you. Fortnightly test.
No, no, sir. I don't think I got it yet.
Yeah, but you took the fortnightly test, right? So then you would have the. Or if you want to practice those questions, so then I can. Yeah, I will tell the learning medium to just send you those questions.
I think I got it now, sir.
Okay, okay, okay. If you yeah, you try those questions and you face any problems, so please don't hesitate to ask me those questions. Okay.
Yes, sir.
Yeah. Okay. So if you guys have taken or activated those tests, so then please complete that and I'm leaving. Okay, guys.
Sir, I didn't get the test questions yet. The fortnightly test.
Fortnightly test. Oh, you don't have the questions.
No, sir. I thought I had it, but now I don't have it.
Okay. So what I will do is that I will tell the learning your team to send you those questions. Okay. Okay, Rishita. So that was, let me check, that was on average speed, uniform speed, and those kind of questions.
Yes, sir.
Check. I have those question. I will just send it to the learning team and they.
Sir, I need to join another meeting for the test, so can I leave this one?
Oh, you have a different test now.
No, yes, sir, right now.
Okay, okay, yeah, yeah. Bye, Rishita.
Bye, sir.
And
Thank you, sir.
yeah, bye, Amna, bye, Akib. Yeah, so you guys complete it. Yeah, yeah, okay. If you have completed that test, you can. And Amna, yeah. So yes, bye, Akib. Allah Hafiz. And yes, Amna. So you also, Allah Hafiz. Yeah, Amna, I'm also going, and you please complete that test, and yeah, so we'll discuss those questions later. Bye guys. Allah Hafiz.